Alrighty, so can you guys see my screen?
Yes.
You can see what I'm going to write?
Yeah.
Alrighty, perfect. Okay. Remind me when we're done to kind of put the dates down and go over that in writing so people that get online and watch this will know where we're at. Okay, so the first thing I want to do, and this is going to be really hard to play the Razy Handy Gamey because what we'll do is I will just have you count off. So you'll have to do it. You'll have to unmute yourself. You'll have to count a number. The next person will just count the next number, and we'll do till there, okay? Now, if I do this, you guys can still see what I'm writing, right? So that way I can see how many people are on. Alrighty, so here we go. So we're going to start off. Let's balance this sucker, and then we'll kind of go from there. Let's go with... here we go. Let's go C3H8 plus O2 yields CO2 plus H2. Let's just hurry and balance that, and then we will get hot and heavy. Let's go for 5. Let's get to 5. Hey, does anybody remember what date this announcement was made? What date? Where to find the video link?
Okay, 1, and I'll go find the date.
Okay.
Canvas says it was October 12th.
Thank you.
Yep.
So I have a 1.
2.
I have a 2.
3.
3. 2 more.
4.
1 more.
5.
There we go. Alrighty. So, who was 3?
Me.
What do you got for me?
1, 3, 3, 4.
1, 3, 3, 4. Anybody back that up?
I can.
Yeah?
I can too.
Alrighty. Okay, so, like I said, there's going to be probably, I think, 5 of them. 5 of them on the test. Okay, so make sure we've got that. Now, from there, let's go right to a limiting reactant because they're probably what I think most of us struggle with the most. And let's say that I was given, 42.6 grams of C3H8 and, 72.5 grams of O2. Okay. How many moles of CO2 will be produced? Now, if you had this class yesterday, try not to respond to this. If today's your day, who can tell me what should jump out at me and what kind of problem? Well, I already told you what kind of problem, but what should jump out at you right here? Nobody?
Is it that they give you 2 things?
Exactly.
And you have to do them both to figure out
Exactly,
which
Richards.
one?
No, you're exactly right. They give me this, and they give me this. They do that, that's going to be a dead giveaway that this is going to be a limiting reactant problem. And all I know is I'm simply going to do both of these to get my answer, and then I'm going to pick the one that is the what?
Smallest.
Smallest. Now, what did I do here that actually made this problem a little bit easier? Anybody recall?
It's in moles of CO2 and not grams.
Yeah, we're stopping at moles. I've saved you that step at the end. So let's start. So I'm going to start with my 42.6 grams of C3H8. Where am I going first? Where do we go first almost every time when given grams?
Molar mass.
Going to molar mass, right? So I'm going to go 1 mole of C3H8 for every... What's my molar mass here? Where do I find my molar mass? Or how do I find my molar mass? Hey, are most of you guys home alone? Or do you have a house full of people? Nobody? If you're home alone, just unmute yourself so you don't have to keep waiting, you know what I mean? If you're in a place that's fairly quiet, just unmute yourself so we can participate better. Okay? So how do I find this molar mass?
Reaction.
No, go ahead.
Now go ahead, Richards.
You do 3 times 12.0011 plus 8 times 1.008.
Okay, that's the what? What'd I call that?
The molar mass?
Well, yeah, but we called that the party method, right?
Oh, yeah.
Yeah, find the party method. So what do we got here? Anybody got this number yet?
I got
44.097 grams.
44.097 grams of C3H8, right? Okay, and that's going to put me into moles of C3H8, but I want moles of CO2, so now I go to my what? What do we call that? We called it 2 separate things, meant the same thing.
The mole-mole ratio?
Mole to mole ratio, or anybody else know the other one? Nobody? The molar ratio. So what's going to go in my numerator?
Three moles of CO2.
So I'm going to go 3 moles of CO2 for every 1 mole of C3H8, right? My moles of C3H8 reduce out. My grams of C3H8 reduce out. And I'll be left in moles of CO2. And what do I get? 2.8 something probably?
Yeah, 2.90.
2.90 moles of CO2. Anybody back painter up?
Yeah.
Yeah? Alrighty, so that's that one. We just kind of hold on to that, right? Now I'm going to do basically the same thing with my 72.5 grams of O2. So I'm going to go 72.5 grams of O2. I'm going to times that by 1 mole of O2 for every what? What's this going to be here?
$31.998 grams.
So 31.998 grams of O2. And I'm going to times that by my new molar ratio. My new molar ratio was going to be CO2 to O2, which gives me 3 moles of CO2 for every 1 mole of O2, right? My moles of O2 reduce out, my grams of O2 reduce out, and I'm left with...
It's 3 moles of O2.
Yeah, sorry, that's what I wrote down. 3 moles. Hey, who's at your door? So, I do that, and I'm going to get just over 2. Because those 3's will just reduce out, won't they?
Yeah.
So I'm just going to basically that divided by that, and what do I get?
2.27.
2.27 moles of CO2. So what's my real answer going to be?
2.27.
Yeah, this is my real answer. This is how much I'm going to get. Okay. And that then is going to trace back to this, which makes that my what?
Limiting reactant.
Yeah, that makes that my limiting reactant, right? Okay, now, from there, the next logical step is a percent yield question. Okay? So let's say, suppose you produced 1.89 moles of O2 in the lab. Okay, what is the percent yield, right? Well, all I could do is I've got to go back and remember that percent yield is actual divided by theoretical, right? So
Do you mean produced CO2?
yeah, can't you see that C right there, Painter?
Yeah, totally.
Yeah, okay, that's what I thought. It was written in invisible ink, that's what it was. Okay, so what did we say actual really was? Where did we get the actual?
It's 1.89.
Yeah, but where did I get it? Who?
Oh, from the experiment.
Yeah, from the lab, right? And then the theoretical always came from the
Math.
right? So it's going to be my 1.89 moles divided by my 2.27 moles, and I'm going to times that by what?
100.
Times it by 100 to turn that into a percent, and what do I get out?
83.3%.
83.3%. Anybody back that up?
I have that.
Yeah, and again, each one of these values have 3 sig figs. My answer probably better have what? 3 sig figs. Okay. Now, as I talked about yesterday, from start to finish, if I go this entire question with the balancing, with stoichiometry, and with the percent yield, that's like 1/3 of the test. Is balancing equations, doing some stoichiometry and percent yields. Okay? If you can do that, you're going to be in good shape. If you can't, you better start asking questions. Okay? Whoa, excuse me. Alrighty, so from there, I do need to talk about something that last year confused a couple of students because of the way they wrote these. Okay, so what they're going to do is there's 2 of these on the test. And they write them in, and they put them in boxes. Okay, and they're going to give you an equation. I'm just going to give you something basic. So I got 2x plus 3y yields 4z. Now listen, it doesn't matter what these are. These are just some compounds. I just need to understand that for every 2 of these, I need 3 of those. And it is going to produce 4 of those. And what they do is they put them in these big long boxes. And they'll do something like this. They'll say, this is my initial. Okay. And then this one will be like at a later time. I don't remember what they wrote right here, but it doesn't matter. It just means at some point, right? And they start with like 10 moles of these and 10 of these. It could be moles. Remember, these equations are written in 2 values. It can be either moles or it can be in what? Nobody?
Molecules?
Molecules. It can never be in what?
Grams.
It's never in grams. That's why we always convert. Okay, so it asks me, there's a question that asks about, it says, why do we bother to put things into moles when we can find their mass and we can find their volume? Because these equations are not written in grams. They're not written in liters. They're only written in moles or molecules. That's it. So let's say that when I first put these 2 things in this beaker, how much Z is there? When I very first start this experiment. Well, go back to my bologna sandwich analogy, right? When I take the bread and the meat out of the fridge, are there any sandwiches made yet? There isn't any, right? So this is a 0. But at some point, these are going to start to react, right? So at some point, if I've used, let's say I've used 4 of these, how many of these have I used?
6.
6. How many of these have I gotten out now?
8.
8, right? Let's say I let more time go. Let's say I let more time go and I would use, or I got to, let's say I got to 9 of these, or I'd use 9 of these. Well, if I've used 9 of these, how many of these have I used?
6.
6. And how many of these have I gotten out now?
12.
12? Right? Because I just went 3 times 3 got me to 9, 2 times 3 got me to 6, 4 times 3 got me to 12. Does that make sense? Remember, that can be in moles or molecules, not grams. Okay? Alrighty, now, there are several artwork questions. And because I only have a few of you on here, and you're probably the ones that started the homework, I will not read you the riot act that I read to my classes yesterday that really pissed me off. But anyway, so here's my 2 pictures. I got a picture and I got a picture. And I'm telling you, this is going to be very similar to what you're going to see on the test, okay? There are several artwork questions, and if you've started the homework, you know what I'm talking about. Now, so what they've got is they're going to give you an equation. So the one we used was A plus 3B is going to give me AB3. And then they did this, okay? They give me that, and then they give me this. Now, what you're going to realize is this, is in this picture, I have 9 A's, if you count them. And in that picture, I have got 18 B's. Okay? Now, based upon what they've given me here, okay, I know that my relationship from A to B has to be 1 to 3. For every 1 A, I need 3 B's, right? But I have 18 B's. If I only have 18 B's, how many A's can I use? Somebody that didn't have this yesterday. How many?
6.
6, right? 6. 6 of those are going to use 18 of those, right? So my B becomes my what? Anybody?
Limiting reactant?
Yeah, B has to become my limiting reactant because it's going to get totally consumed, right? So, what am I going to draw over here? Well, I know I'm going to have 6 AB3s, aren't I? So I'm going to have 1, 2, 3, 4, 5, 6. Each one of these are going to have 3 B's around it. But I'm also, in my beaker, I'm going to have some what?
Leftover A's?
Some leftovers, right? What did we call that? Is that you, Fish?
Yeah, and I wasn't there, so I have no idea what you called that.
Yeah, what do we call the stuff that's left over? It's in
Excess.
excess, right? In excess, yeah, somebody remember that, right? So, how many lone A's are going to be left over?
3.
I'm going to have 3 A's left over like this, and that's what my final product would look like. Okay? And like I said, those of you that have started the homework, I'm going to assume have seen these. If you haven't, there's what? Painter, are you done with the homework?
Yeah,
Was there 2 or 3 of these on there?
something like that.
Something like that. But I know there's a couple, at least a couple, and I want to say there's like 4 of these. 4 on the test. They're all going to look something like that. Is that making sense or no?
Yes.
Yeah.
Okay. Alrighty, so that's that. Alrighty, next topic is, okay, now I got a couple of emails last night about these, so make sure, well, before I do that, write down these two conversions on your 3x5. Okay, 1 kilogram is equal to 2.2 pounds, and 1 kilogram is equal to 1,000 grams. And for those of you that are B-Day students, here is my 3x5. I forgot to put that up at the beginning. Want to make sure I get that up there. There's the front. And you can always go back and pause this. Okay, and here's the back. And that's all stuff, you know. Alrighty, now, the next thing we need to do is we've got to talk about redox half reactions. Now, they're going to give you two different kinds of redox questions. One is going to be a straight up assign the numbers, determine if it's redox. And then the other one is going to be actually write, well, you're not going to write because it's multiple choice, but choose the half reactions that match. So this is what we're going to do. I'm going to change this from what I did yesterday to give you guys some more examples. Does that make sense? And I just realized that I forgot to bring home a periodic table. Crap. But this will work. So let's say I go with, this will work. So let's say I go with calcium 2 positive plus, does anybody have a periodic table? What's right below O? What's right below O? Sulfur?
Sulfur.
Plus sulfur yields sulfur. No, I don't want to do that. Oh, shit, and I forgot my whiteout. Let's go strontium. Is strontium a 2 positive? Is strontium below calcium?
Yeah.
Okay, so this will work. So let's go calcium plus strontium yields strontium 2 positive plus calcium. Now, a lot of you missed the question that was about this because you forgot to put the states. Just to understand that if it's an ion, which means it's got a charge, it is always going to be AQ. AQ. If it's elemental, for most of these, it's just going to be a solid. Okay? So I've got that. So here is a good example. Now, remember that I'm basically going to have two equations. I'm going to have calcium 2 positive aqueous, right? Then I'm going to have strontium solid. Okay? Now, for calcium 2 positive to become calcium solid, what does it have to do?
Gain electrons. Which means reduce.
It's going to gain 2 electrons. Because 2 positive times 2 negative is a 0. Over here it's a 0. They've got to match up, right? Strontium, to create strontium 2 positive, has to do what? Somebody has a parakeet.
Lose 2 electrons?
It's got to lose 2 electrons, right? So what happens is this, just to understand this, is remember that my electrons have to be where?
You got to be on the opposite sides of the yield. Right?
Exactly, they've got to be on opposite sides of the yield. And just know that my charges have to balance out, right? So that 2 positive and that negative gives me a net 0 over here. Well, this net 0 is there because that's a net 0. Same thing here. This strontium elemental is a net 0. These have to be a net 0. Now, if I go back up here and I wanted to name, or I wanted to number these, here's strontium's elemental. It would have a number of what?
0.
0, right? Calcium 2 positive, it's obvious it's a 2 positive, right? I go over here, this strontium is a 2 positive, this calcium is a
0,
right? Well, if I remember the mnemonic device oil rig, right? Calcium went from a 2 positive to a 0. Well, the only way to go from a 2 positive to a 0 is to do what?
Gain electrons.
Gain electrons. Reduction is gain. So that means my calcium was reduced, which by default, it can only pair with one thing, and that makes it my what? Oxidizing agent, right? Well, if that's reduced, do I even have to worry about this? I know, because there's only 2 of them, it has to be what?
The opposite.
Yeah, it has to be oxidized, which makes it my what?
Reducing agent.
Yeah, your reducing agent. And I want to say there's 1 or 2 of these. I know there's 2 or 3 of these, where you just assign them numbers, do the math, but I know there's 1 or 2 where you have to do the half reactions. Okay? Now we're going to let's do one that we just do the assigned numbers again, because I seem to have gotten a bunch of, I know I can't see your faces, but I envisioned a bunch of blank stares. Okay? So let's do, here we go. So I've got Al plus HCl yields AlCl3 plus H2. Sorry, is that better?
Yes.
Okay, so there we have it. Alrighty, so what do I know about aluminum right here?
It's going to be 0.
It's going to be 0 because it is elemental, right? What about H2 over here?
It's also 0.
It's also 0 because H2 is one of those what?
Diatomics.
7 diatomics, right? Now, chlorine. What do I know about Cl when it's bonded to H? What does chlorine usually like to be?
So 1 minus.
It's a 1 minus, right? Which then, no matter what, makes my H become a what?
1 positive.
1 positive, right? I come over here. Cl is still a 1 minus, but there's now 3 of them, which gives me a net what?
3 positive.
3 negative.
A net 3 negative, which means my aluminum has to be a net 3 positive, right? So my aluminum went from a 0 to a 3 positive. Well, the only way to go from 0 to positive is to lose what?
Electrons.
Lose electrons. So oxidation is loss. So this has to be oxidized, which makes it my, anybody besides Painter or Richards?
Reducing agent.
Reducing agent, right? Now, which one of these is reduced? Anybody know?
Sorry?
Chlorine's reduced. So look, over here's chlorine. Chlorine's a 1 negative. What's chlorine over here?
1 negative.
So it didn't change sign, so it doesn't involve, it's not involved in this. But my H goes from a 1 positive to a 0, which means it did what? Did it gain or lose electrons?
Gain electrons.
Gain electrons, right? So that means it was reduced, which makes it my what?
Oxidizing agent.
Oxidizing agent. Okay? Alrighty. Now, with that, let's do one more. Whenever they give you a combustion reaction, okay? Combustion is always redox. And typically for what we're doing, combustion is going to look like this. It's going to be a hydrocarbon plus O2, and it's going to yield CO2 plus H2O. Now a hydrocarbon, it's right in the name. hydrocarbon contains hydrogen and carbon. That's it. So like if I gave you C2H2 plus O2, that's going to yield CO2 plus H2O. Now look, O2 is one of those diatomics. So what is its oxidation number?
0.
It's a 0. No matter what, it's a 0. Okay? Over here, it's a what? Each one of these spots is the same. Here, it's a 2 negative because that's what it usually likes to be, which makes sense because H is usually a what?
1 positive.
1 positive, and I got 2 of them, which gives me my net 2 positive, my net 2 negative, right? Same thing here. O is a 2 negative, but I got 2 of them, so that gives me a net 4 negative, right? Well, that means my carbon's got to be a 4 positive, which if I go back to what I told you, and you roll on your periodic table, carbon likes to be a 4 plus or minus, right?
Yep.
Okay, so here, H again is typically a 1 positive. There's 2 of them, so that's a net 2 positive. Now, this is a little different animal here, because look what happens. It's a 2 positive, which means this carbon side has to be a net 2 negative, right? But I've got 2 of them, so each one of them must be a 1 negative. Okay? Now, my oxygen went from a 0 to a 2 negative, right? Well, that must mean it is what? What did it do? Did it gain or lose electrons?
Gained.
It gained, so that must mean it is reduced, which makes it my, by default, oxidizing agent. Now, did my H change signs or change numbers? No, it's a 1 positive and a 1 positive, so H isn't part of this. But look at my carbon. My carbon went from a 1 negative to a 4 positive. So it had to have done what?
Lost electrons.
Lost electrons, which means it was
Oxidized.
oxidized, which makes it my reducing agent. Now, notice, oxygen will never be oxidized. Oxygen will always be reduced. That's why they call it oxidizing agent. Oxygen is an oxidizer. Oxygen will always be my oxidizing agent in that case. Okay? So pay attention to that. All right.
So can I ask you a question about that one?
Yeah, buddy.
So each one's like the C2H2 has to have a net charge of 0 in that one, right?
Exactly.
Like all the pieces have to have their own net charge of 0.
Yep. I want to keep that a 0, that a 0, that a 0, that a 0, which is how I kind of, so like, that's actually a really good question, Richard. So if you go back, and it's been a while, but when I had you write on your periodic table, at the top of carbon's column, it said 4 plus or minus. Do you guys remember that?
Yeah.
So now, that means that typically, carbon wants to be either a 4 positive or a 4 negative, right? Over here it worked. Carbon's a 4 positive. But, over here that didn't work. Well, that again, it's never 100%, right? So I'm just looking at it saying, well, based upon the math, each carbon here can only be a 1 negative, which can happen. It's not a guarantee, it's a general trend. Does that make sense? So when I do this, start with what you know, work to the other one. Does that make sense, Richards?
Yeah, and that's why the carbon went from a 1 minus to a 4 plus.
Exactly.
That's why it's the RA.
Exactly. That's why it was oxidized, because it gained. It lost electrons, and the only way to go from a 1 negative to a 4 positive is to lose electrons. Does that make sense?
Yeah.
Okay. Alrighty, so I do need to talk about a couple of things. So, okay, so these are things I've written down. 99.999% of the time, oxygen is reduced, which makes it the oxidizing agent. Which is probably why they call it the oxidizing agent, because it involves oxygen. Oxygen oxidizer. Okay? Also remember the law of conservation of mass. Okay, which is why we balance the equation. Sometimes instead of mass, I write matter right here. Same thing. Okay? Now, there's a question that they ask that goes something like this. And I mentioned this earlier, but I wanted to write it down in case kids get on and watch this video. Why do we bother to convert to moles all the time? Anybody pay attention to what I said? Dude, you guys want to hear something funny? I turned around and looked at the wall behind me just now. Anybody know why? Not a soul? Well, because remember in my classroom, I usually have to turn around and make sure my stuff's in the middle still. And I'm like, what am I doing? It's right there on my screen. So, anybody know the answer to this? I actually said it earlier today. Why we bother to convert to moles all the time? Anytime we're doing those equations, we're always going to moles. Nobody? Well, think about this. When I go in the lab, okay, do I measure things in moles?
Not really.
No, I measure things typically in what?
Grams.
In grams, right? But all my equations are only written in two things. They're written in either, what did I say? They're written in
Moles or moles?
moles and molecules. They're never written in grams. So I go in the lab and I do it in grams, but that doesn't transfer. So I'm always going to moles because that's what my equations are written in. Okay? Okay? I can't give you guys all a creepy wink, but I would probably creepy wink that. Okay? Alrighty, so now I want to wrap this up with two questions. I've got 6 minutes. So we're going to go Razy Handy Gamey. Okay, we're going to go Razy Handy Gamey. And we're going to do this. Alrighty, so how many? I'm going to change these numbers though from yesterday. How many molecules of C6H12O6 are in a 10.00 pound bag of sugar? Okay? That is the chemical formula for sugar. Okay? So I know that I'm going to start with 10.00 pounds. I want you to turn this into molecules of sugar when you're done. Okay, and we're going to do the same thing. Just when you get the answer, get on and give us a 1. Next person get on and give us a 2. And let's go to 7. That gives me about 1/3 of you.
One. 2. Three.
4.
5.
2 more.
Am I 6 or 7?
You would be 6.
Okay, 6.
I need 1 more.
7.
Alrighty. Okay, who was 4?
Me.
Who was that? Alexa?
Yeah.
Alrighty. So, where do I got to go first?
You have to convert kilograms to pounds.
Okay, so I'm going to go, what's going to go where here? What's this first conversion?
1 kilogram over 2.2 pounds.
1 kilogram over 2.2 pounds. Okay, then I'm in kilograms. I'm going to go to what?
Grams to kilograms.
And it's going to say what?
1,000 grams over 1 kilogram.
Okay, we're good to there. Then I'm going to go to what?
1 mole of sugar.
So 1 mole of C6H12O6 for every...
Is it the atomic weight?
molar mass.
Oh, okay, 180.156.
180.156 grams of C6H12O6, right? Now, $6 million question. If I stopped right there, I would be in moles, which is what we did a lot, right? But this asks for molecules. Do you know how we go from moles to molecules? Still you, Alexa.
I don't.
Okay, so who knows, not named Michael, what this conversion should be? Anybody? Celeste, you got an idea?
No.
No? Hannah? Richard, you got it?
Is it the Avogadro's number?
Avogadro's number, yeah. So I'm going to go 6.02 times 10 to the 23rd molecules for every what?
1 mole.
1 mole of C6H12O6. And that is molecules of C6H12O6. Okay? So, my moles reduce out, my grams reduce out, my kilograms reduce out, my pounds reduce out. I do all that math, and I don't have this answer, so hopefully somebody gets this right. Anybody get to here?
I did.
Hannah, what do you got? Was that you,
I got
Hannah?
1 point. Yeah. I got 1.519 molecules of C6H12O6.
1.519 molecules. How do you have 0.519 molecules?
Because there's 4 6s.
Okay, that's not what I'm asking.
Oh.
You're telling me, you're saying I have just 1.519 total molecules.
That's what I got.
I got 1.519 times 10 to the 25th power.
Oh, yeah.
Ah, you see what I'm saying now? You were telling me I had a part of a molecule here. I can't have a part.
It's the 22nd power, not the 25th.
I
22nd?
got 25th power also.
Who's that?
Yeah.
Okay, give me a second. We need to walk through this because this is really, really, really important. Everybody watch. Okay? Now, here we go. So look. Good thing I have a light up calculator. So this is what I do. I open a set of parentheses and I type all my numerators in. So I got 10.00, right? Times. Now, I don't need that one because that's a 1, right? But I do need that one. I'm going to times that by 1,000, right? Times that by, do I need that one? I don't, but I do need that one, right? So I'm going to go 6.02. How do I type this in? I know I showed you. How do I type this in?
Second comma.
Second comma, 23, right? And then I close my parentheses. And I'm going to hit the divide key. I'm going to open a new set of parentheses. And then I'm going to type all my denominators in. Which is going to be 2.2, right? Times 180.156, right? Close those parentheses and I'm going to hit enter. And that's what I'm going to get. I get 1.519 times 10 to the 25th. That would be molecules of C6H12O6. Painter, what'd you do wrong?
Missed the 1,000.
Missed the what?
I missed putting in the 1,000 in my calculator.
I got you. Alrighty. So, just make sure you have this written down that 1 mole equals 6.02 times 10 to the 23rd molecules. Make sure you have, that's an equality, and then you can use that conversion factor either way. Okay? Now,
Can I ask a question on that last one that we just did?
yeah.
So, when I do it in mine, I don't do the 10 to the 23rd in here. I just write out the number and then I move it to the left and then I add that on to the power. So as you move the decimal to the left, does that make your power go up or go down?
It goes up.
It goes up?
Yeah.
Okay.
And that's fine. I'm cool with that. Okay? Alright, can we do one more? Do we got time to do one more?
Mhm.
Yeah? Okay. So, I have completely screwed up my notes. That goes with that. This is with us. Alrighty, so let's do this. I did not get to this in every class because some of them we just ran out of time. But let's do this one because this is actually a really good. It's not the exact same, but it's pretty much the exact same. Well, let's just do it. So I want to ask this. So I'm going to say how many grams of sodium are in, let's go with 9.76 times 10 to the 24th molecules of sodium. Okay? So look, you're starting in molecules. I need to go to grams. Okay? Now, we're going backwards, right? Last time we went from pounds to molecules. Now we're going from molecules to grams, right? So what is that going to do with that Avogadro's number relationship? Anybody know? Crap. Check that. What's wrong with that? Anybody know what's wrong with that question? Nobody? What does sodium exist as?
Oh,
Is sodium a molecule? I guess I could have a molecule of sodium, but typically not. Let's just start in atoms here. It's the same problem. That's just the wrong word to use right there. Start in atoms, go to grams. Let's go for 9 hands. Let's up the ante a little bit.
one.
Two.
What number would this be?
I think it's 3, ain't it?
Okay.
I got 3. I need, what did I say? What did we go to? 9? I need 6 more, people. Be brave.
4.
4. Okay, I'll do 5.
Okay. 6. There we go. 3 more. Bless you.
Sorry, I realized I turned off my camera and not put myself on mute for that.
You'll be alright. It don't bother me none. I like having the company. My wife works and I'm an empty nester, so. Am I going to get 3 more?
What number are we on?
7.
Okay.
So you're 7?
Yeah.
Okay. 2 more? Alright, well, we got to get going so we can get you guys off here. So look, this is what you got. So I know that I'm going to start with 9.76 times 10 to the 24th atoms, right? Now, before I go to grams, same idea, I've got to get to moles. Well, 1 mole of Na is 6.02 times 10 to the 23rd atoms. Because remember, that number can be in atoms. It can be in what? What are the 3 things that number can be in? Got a giggle out of some of you, right? It's in atoms, it's in
Formula units.
formula units, or it's in
Molecules.
molecules, right? So that's going to put me into moles of Na, but I asked for grams of Na. Well, once I'm in moles, I'm just going to take and put what in my numerator?
The molar mass?
The molar mass, right? What's the molar mass of sodium? Anybody got that?
22.990 grams.
22.990 grams of Na for every 1 mole of Na, right? My moles of Na reduce out, my atoms reduce out, and be left in what? What's my answer? Anybody got that?
372.
Say that again. I heard a girl's voice.
It's 373 grams.
373 grams of Na. Anybody else get that? Yes or yeah, you got that, Hannah?
Yeah.
Alrighty. Okay. Now, I'm going to hurry and write this stuff down so I can get this uploaded and shared, but this is what we're going to do. So, I don't know. They put out guidelines. The school did with times and stuff, but yeah, we all know how Mr. Denton rolls, right? So this is what we're going to do. Okay? We're going to review and answer questions Monday. What day is Monday? Monday 11/23, right? At 7:45 a.m. Okay? This is everybody. And then this is everyone. Okay? I'm going to try this. Let's see what happens, right? And that's because the test is kind of causing some problems. Okay, so this is what we're going to do. So on Tuesday 11/24, pay attention. I am going to open the test at 8 a.m. 8 a.m. You have from 8 a.m. to 12 p.m., which is noon, to get on just like we're on right now, and I will give you the password and I will watch you take the test. Does that make sense? Do you guys all understand what I'm saying? Okay, so that day from 8 a.m. to noon, you're going to get on the meet. I will give you the password then. And you will have 2 hours to take it. Okay? But it ends at noon, so I wouldn't get on anytime after 10, right? You'll have 2 hours to take it, and I will sit here and I will watch you take that test. And it'll be, it's one of those things. You'll still have a 3x5. And it's one of those things that, yeah, I'm sure somebody's going to say, well, what if someone's probably going to try and cheat. But there's only so much I can do. You know what I'm saying? But understand that this is the day. It's this or never. Do we all understand that?
Yep.
So what I need for you 22 people to spread the word to your friends. Tell them to get on, watch this, and then you... I don't care if you want to snap it out or Instagram. I don't care how we get this word out. But we ain't on vacation. Okay, this is chemistry, college chemistry. I cannot slow down. If we do, we're going to get to the end and every one of you are going to be screwed. Okay, we've got to maintain our pace. We'll just push the lab back until we come back. We'll start chapter 10 or start chapter 6. We'll probably end up just doing 2 labs in chapter 6. Okay, was there a question? Did somebody have a question? Do we all understand? Yeah, go ahead.
I do have a question. So the time periods you gave us are also time periods where, for the guidelines, we'll have classes, right? So.
Okay, so I thought about that. And how many of you are in a class that is going to require you to report in? You do?
Probably a lot of us, yeah.
Probably a lot of you.
Yeah.
So, what time do the guidelines end?
12:15. So it's 8:30 to 9:15, and then it goes all the way till 12:15.
So, what if I push this up to 7:30 and pushed it back to like 2?
That would be good.
That should be good.
Okay, so let's do that. So, we'll do this. We'll go 7:30. Man, that's going to suck for me. 7:30 a.m. to, what did I say, 2 p.m.? Okay. Still, you're going to have 2 hours to take it. I can do that. What time does your first class start?
8:30.
Oh, so yeah, I mean, you're going to have plenty of time. Okay, that's fine. Yeah. We can do that. Yeah, that's fine. We can do that. And then that way we're all in the same place. And then when we start on Monday, what's that Monday?
It would be 8:30 to 9:15.
No, I mean just what is that Monday?
For the date.
Yeah.
22nd?
No, the Monday after. Is that like the 1st or something?
Oh, it's the 30th.
The 30th. So then we'll just start on chapter 6 that day. That work?
Yep.
Alrighty. If you have any questions, drop me a line. But I'm telling you what, get your homework done so that when I get on Monday, we've got questions. Alrighty? Well, then
Good.
Oh, shit. Oh, wait a minute. Because the problem is that I can't give this test in 45 minutes. You know what I'm saying? So I can't. Yeah, this will have to work. If we weren't testing, it'd be different. But I don't think most of my students are going to finish this test in that window. Do you guys understand what I'm saying? Some of you will, but not all of them will, which is why I've got to have. We'll just do this. We'll be all right. Yeah. We just have to make it work. So that means maybe I'll have to do more classes on Monday. Maybe I'll just get online that whole morning. We'll figure it out. Alrighty. If you have questions, drop me an email. Hopefully some of my students watch this video. Alright, talk to you guys later.
Okay.
Okay, see ya.
Yeah.
Yeah, thanks, Sam.
Yeah, buddy.
Thanks, Dad.
Stop.